Hello everyone. So in the last video we have seen a complete picture of this IR sensor pair and importantly IR sensor module and yes, how we can read the values from the sensor module, how we can create analog connection. Okay, so these things all okay, and also the code, right? So you might have seen this code. So this monitoring of the values are here, and we are trying to give an alert when the object is closer than 15 centimeter, right? Let's say 15 centimeter. So this value I explained, right? What is this value? This value is the value you found out to be the analog value for 15 centimeter, and also you are finding out whether the analog value is increasing or decreasing when the object is coming close. So I am assuming this is decreasing when the object is coming close, so I have created a lesser than operator, right? So if you found it is increasing, you have to do the opposite operator, greater than. Okay, that's fine. And so this was to control an LED. So if the object is closer than the particular 15 centimeter range, then the object code will switch on a red LED. Okay, alert people. Then if the object is moved away and it is outer, it is how can I say, if it is away or if it is what can I say, outer than the 15 centimeter area. So you understand what I am telling, right? Distance, then we switch off that particular LED. Okay, so monitoring, serial printing and monitoring, and switching off. So I made a small mistake, so I didn't declare the X value here. So if you are typing that code I'm sorry guys, you will get an error, right? Obviously, so you have to declare the X value here in X. Okay, so that is must, right? Fine, now it will work. So I will quickly compile it and see. Compilation will be success, obviously. See, done compiling. Okay, all good. So now you can take this code and implement and see what happens, okay, with the connections that I explained in the previous video. So now we are all good. Yeah, so now what I'm saying is, okay, sorry guys, so let's change this task a little bit different. Okay, so I'm saying, okay, this switching on thing, okay, if the what you call object is closer than 15 centimeter, we switch on an LED, red LED. If it is more than 15 centimeter, we switch off a red LED. Okay, so this is boring. So what I want is, I want something to happen like this. Okay, like what? Like this. Okay, let's say. So let's say I have the sensor pair here. Okay, and this object, we have an object here, right? So when the object, so there's an LED connected to pin number 7 or something, so we don't care about that. Okay, so the object is coming towards the IR sensor pair, the brightness of the LED should slowly increase. Okay, when it is coming towards. Okay, if the object is going away from the IR sensor pair, the brightness of the LED should go down. You understand what I'm saying? Okay, so when the object is very close to the IR sensor pair, the brightness of the LED should be maximum. The brightness of the LED should be maximum. When the object is most away at the maximum point, okay, I mean the 1000, let's come to the later. At the maximum point, the brightness of the LED should be decreasing, minimum. That means 0. Sorry guys. So an analog indicator of the position of the object from the IR sensor pair. So earlier we had a digital indication to find out, okay, this is within the 15 centimeter range, or this is I'm sorry, away from the 15 centimeter range. Now it's not the case. We are going to have an analog indication. Okay, so is it coming to us, how closer it is or how far it is, like that. Okay, so you might get some click because we studied, right, how to take an analog input and how to convert it into an analog output, okay, using map function, and how you can do that. Okay, we saw that with the variable resistor or potentiometer. Now we are supposed to do with the IR sensor panel. That's all. So I guess you can do. Otherwise I will simply write the code and let's see. Okay, so we are all good. We read the analog input value from the IR sensor. So what we have to do? We have to do a map function and convert it what? Exercise. Okay, and convert it to analog output. Okay, So let's declare a variable y. So you know what I'm doing, right? If you don't understand, you have to watch the video on the topic where we have seen how to take an analog input and how to make it into an analog output. Okay, so I guess you have watched the video and I'm trying to do the implementation. So what is y? Y is a map function, right? Because we are going to convert this 0 to 1023 range to 0 to 255 range. You know, right? For analog input we have 0 to 1023 range, and for analog output we have 0 to 255 range. Okay, so x is the input, so I'm taking the x input and I'm giving the initial range values 0,023 and I'm giving the upcoming, that means output range values 0 to 255. You know this, right? I explained it again and again. Now we have to give an analog out. So let's say pin number 7 has the LED, right? So I'm going to give the analog output to the LED. Okay, so I will write analog write. Okay, so already we have said it, right? Pin mode 7 output, only we didn't say digital output to analog output. So this thing is common for both digital and analog outputs. So I'm doing an analog write. Okay, so pin number 7 and the y value. So if you followed up my videos properly, you know what I am doing. There's no question on that. Okay, so serial println also there so that we can real time monitor the values. Okay, so this looks to be make sense. Yes, this makes sense. Wait. Okay, so the problem is what? When the input value 0 to 1023 it is increasing, let's say, and this will what do you call this output will increase. When the output value is input value is decreasing, output will decrease. It's very normal. Okay, but my question is what? When the object is coming closer, output should increase. When the object is coming closer, the brightness should increase. When the object is going away, brightness should decrease. So we have to make sure when the object is coming closer, whether this input is increasing or decreasing. So same thing that I explained earlier, some kind of thing, because I didn't know when the object is coming closer whether this thing is, this input is increasing or decreasing. Okay, so what you have to do is you have to first bring your object closer to the sensor. Okay, move towards the sensor and see whether the input value, and check, remove these two lines. Okay, and check whether this input, that means the x value, that means the analog input value is increasing or decreasing. Okay, if you find when the object is coming closer the analog input value, that means x value, is increasing, then your logic is correct, because here also if the input increase, then you give the output increase. Okay, so that means what? Input increase, brightness increase. Okay, for that means what? The object is coming closer and the analog value is increasing. If you find so, then everything is fine, right? Because x is increasing in the range, output also increasing. Okay, if this is so. In case if you find when you are bringing the object closer, the analog value is decreasing. Okay, but anyway, for us, object coming closer, output should be increasing. But let's say you are finding analog input is decreasing. Okay, but anyway you have to make the output to decrease. So the mapping is happening between the analog input and output. So here you have to reverse the map function if it is so. You understand what I am telling? Okay, so how to reverse it? This way. I told you this, right? 255 and 0. If you do so, you know, you bring the object closer, this value is decreasing. Okay, but since we have reverted it, since the analog value is, if the analog value is input is decreasing, output will increase. Okay, so what is the meaning of it? Object comes closer, analog input decreases, output increases. Gotcha? So what we want is object come closer, output of brightness increases. So the same, right? This is coming closer, this increases, no doubt. Okay, so just hold on guys, I will follow up in the next video because I am almost near to 10 minutes here. Just follow me up in the next video.